Every single year, thousands of students lose easy marks on the exact same Cambridge 0625 physics data questions. It is literally like there's a hidden matrix of patterns in these exam papers. Well, today, we're decoding the whole shebang. We're zeroing in on terminal velocity and ticker tape practicals, and exactly how you can translate your physics knowledge into undeniable top-band marks.
Picture this scenario. 3 students walk into the exam to calculate terminal velocity from ticker tape data. Student A rounds their numbers way too early in their calculations. Student B completely forgets to include a unit on their final answer, a classic, heartbreaking mistake. And student C? Well, they describe the physics flawlessly, but completely fail to quote the experimental data. So which one of these students scores full marks? Absolutely none of them. Ordinary revision completely fails when you don't actually know the examiner's secret rulebook.
Now, what's really interesting about this slide is the exact journey the examiners expect you to take. If we look at the Cambridge syllabus context right here in Chapter 2, Forces and Motion, there's a very clear logical progression. You see how we move from standard forces like basic speed, velocity, and acceleration straight into motion graphs and recording motion, which, by the way, is exactly where our ticker tape data fits in. And then it goes directly into freefall. It's like a giant puzzle. The examiners are testing a highly specific interconnected web of concepts here. You really have to see that bigger picture to secure the highest marks.
But here's the painful reality, guys. Simply knowing the physics isn't enough to secure those top band marks. You can have this masterful understanding of free fall, perfectly visualizing resistive forces balancing out gravity, and you can still lose grade boundaries. Why? Because of minor, completely avoidable exam technique flaws when you're handling practical data. It is incredibly frustrating, I know, but it's also completely fixable once you know exactly what they are looking for.
So, let's rapid fire through the most common data analysis mistakes pulled directly from examiner reports. Marks literally slip away in an instant when you have missing units on final answers, or when you're rounding numbers way too early in multi-step calculations. Examiners are actively looking to penalize vague explanations of your apparatus. Same goes for graph axis errors, poor scales, and really weak practical improvements. But the absolute biggest killers? Identifying the wrong variables entirely.
And drawing conclusions that just aren't supported by the data. Which brings us directly to this big, scary number right here, 0. 0 is exactly the number of marks you're going to get if your conclusion is not supported by the data, or if you base your entire answer on the wrong variables. Actually, scratch that. It doesn't even matter if you have the most beautiful handwriting in the world, or if your essay reads like poetry. Without anchoring your reasoning in the actual data provided, you get absolutely nothing. Okay, let's get our first quick win. This breaks down the exact apparatus and data checks that examiners demand for ticker tape practicals. Let's look at the table design first. You need clear headers with the correct units included. No exceptions. For graph scales, your graph has to cover more than 50% of the page with uniform intervals. If you squeeze your graph into a tiny little corner, you lose marks. When it comes to calculating gradients, you are required to use a large triangle and always show your substituted values. And for data checks, you have to actively identify anomalies and assess the reliability of the results.
Now listen closely to this part. In a moment, I'll show you the examiner clue that changes the answer completely. But first, you really need the framework that makes that clue obvious. Because honestly, if you don't grasp this underlying framework, that clue isn't going to help you at all, and you'll just keep making the exact same mistakes as everyone else. So here is the core 4-step methodology to structure every single high-mark answer. Step 1, the concept. State it using the correct terminology. Step 2, evidence or data. Pull this directly from the source table. Step 3, scientific reasoning. You need to link that specific data right back to your initial concept. And finally, Step 4, examiner wording. Make sure you are using exam-safe words to actually fulfill the specific command word requirements. If you lock in these 4 connected steps, you literally leave no room for the examiner to deduct marks.
Let's apply Step 1 of the framework right now, the core concept. Freefall terminal velocity is defined as the constant maximum velocity reached by an object falling through a fluid when the resistive force equals the downward force of gravity, resulting in 0 acceleration. Lock this exact Cambridge-style phrasing into your brain. When you drop these precise words onto the page, you are screaming to the examiner, "Hey, I know exactly what I'm talking about."
Okay, let's dive into this. It's time to actually test the framework with an interactive challenge. I'm going to show you a classic student response to a ticker tape data question. I want you to read it and see if you can spot the exact error that caused this student to lose valuable marks. Think you can spot it?
All right, look at the flawed answer on the left.
The ticker tape dots get further apart, so it is accelerating until they stay the same distance. I mean, it feels kind of vague, right? It totally lacks precision. Now compare that to the top band answer on the right. The increasing distance between consecutive dots on the ticker tape indicates constant acceleration. When the distance between dots becomes constant, acceleration is 0, indicating terminal velocity has been reached. Velocity equals distance divided by time for these constant dots. Do you see the incredible difference in structure there?
If we act as the examiner for a second, we can break down exactly why that top band answer triggered all the hidden method marks. First off, it uses correct terminology, words like acceleration and terminal velocity. It fulfills the command word requirements perfectly. It references specific apparatus features, namely the distance between consecutive dots on the tape. And crucially, it includes the correct method and equation. The flawed answer? Well, it had the right general vibe, sure, but it completely lacked the specific source page evidence and scientific reasoning that our framework demands.
So remember that examiner clue I promised you a few minutes ago? Well, here it is. Evaluating accuracy versus reliability. Identifying anomalies in ticker tape data and suggesting practical improvements is exactly what separates the top-tier A-star students from the rest of the pack. When examiners ask you to check the data or suggest improvements, they are waiting to see if you can spot an anomaly that affects the reliability of the results or a setup issue that affects the accuracy of the experiment. That right there is how you beat the data matrix.
But wait, let's spike the stakes just one more time. You have the ultimate framework now. You know how to structure your answer, and you know the right terminology. But what if you write out this perfectly sound physics explanation, quoting all the correct data, but the question actually asks you to evaluate the investigation? Then what? Welcome to the command word trap. This is why your perfectly correct physics might still score exactly 0 if you misread the prompt. You could have the most beautiful framework in the world, but if a question says evaluate and you explain, well, everything falls apart. You're answering a question the examiner didn't actually ask, and they cannot give you marks for that, no matter how brilliant your grasp of physics is. And that creates a massive, unresolved problem for your exam strategy.
That command word trap catches out even the most prepared students every single year. So ask yourself, are your exam responses actually answering the question, or are you just showing off physics facts you memorized? Knowing the difference is absolutely everything. Door 2 opens in our next explainer, decoding command words. We're going to dive into the deeper code that decides your mark band, and it is a mandatory watch if you want to secure those top grades. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Catch you in the next explainer.